Here is a 3D printed telescope that uses 76mm Maksutov-Cassegrain optics, which were purchased from a surplus shed. To start, most of the design information I used came from a thread on Cloudy Nights that specifically discussed these optics. Here's what the telescope looks like. It's mounted in a tube ring that allows for rotation, and the focuser is also 3D printed. I still plan on adding a dew shield and a lens cover, but those are not done yet. Looking at a cross section here, you can see the primary mirror, which is collimatable. The secondary mirror is also adjustable for collimation, and as mentioned, the focuser is 3D printed. As are most of the components in the telescope, I should mention that the primary mirror sits on a 3D printed TPU component, and there are M3 screws used for collimation and the assembly of several components. Here's a brief exploded view of the CAD model, and then I'll walk through assembling it with the actual 3D printed parts. So this is what the meniscus lens assembly looks like. This ring here is the outer ring which holds the meniscus lens. It's got a brass insert as well as an M3 nut used for collimating. The lens itself here fits in a smaller ring which gets pushed into that larger ring. Then there's a M3 screw here which will later push against the faceplate, and one which will pull against it. So here it is completed. And here what I'm trying to show is that there's one screw here which can be unthreaded in order to push the plate away, and then the other screw can pull the plate towards the meniscus lens and lock it in collimation. The primary mirror is pretty similar, so I'll try and go through that quickly. There's a plate which holds the mirror and then a ring which pushes against it and holds it just kind of along the perimeter. There's an internal baffle here which gets pushed on top of, or rather through, the primary mirror. Now here's the completed focuser, but I will show one of the prototype versions just to show the assembly process. The actual focus ring, which you rotate to focus, gets pushed over this back part, which will then hold the eyepiece, or the star diagonal rather. And then those two components are going to get threaded onto what will later be the back of the telescope. You can see on the inside here I've used some aluminum from a can just so that the layer lines rubbing against each other don't cause any problems. And there's a key in place too, so that as the focuser rotates, it does not rotate the star diagonal with it. So the primary mirror gets a TPU backing for support and is held in place by collimation screws. I also add some internal baffles to this section and more inside the main tube. Both optical assemblies have a little bit of room to move and adjust the spacing vertex to vertex, which by Cloudy Nights approximations, they seem to assume it was going to be around 106 to 110 millimeters, so I kind of aimed for something between that and then made adjustments as I saw fit. Relatively small changes between the distance of the primary and meniscus lens adjust the back focus significantly, so you can use the collimation screws here a little bit for the purpose of focusing. I believe that if the spacing between these two optics is not ideal, you'll probably end up with a fair bit of coma as well, which I haven't really had a chance to check or address, but it should be adjustable if that does end up happening. You can see here I'm putting in screws into the side of the telescope. Those go in and they hold the primary mirror in place, but otherwise you can undo those screws and then move the whole primary mirror assembly, and that should help make some adjustments. So that's the final telescope minus the tube rings. For collimation, I tried to use the DSI method, making adjustments to the primary mirror to correct for on-axis coma, and then trying to make the remaining defects radially symmetric by adjusting the meniscus lens. This might not be a legitimate method of collimating a Maksutov-Cassegrain, but it seemed to work okay for my purposes. Here's a video of the moon, and then I zoom into the Terminator, and you can see that the sharpness is fairly reasonable for a $40 optical set. So that's it for this little project then, and I will add these files to Thingiverse once I get a lens cap and a lens hood finished.